Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss about the problem vertical width of a binary tree. So let us read the problem statement and see what we can do in this problem. So you will be given a binary tree which will have n nodes inside it, and we have to find the vertical width of that binary tree. For example, let us say that we have been given a binary tree which has the nodes 1, okay. Then for 1 the left child is 2 and let's say the right child is 3. So suppose if we have been given this particular tree here. So what we can say is that the vertical width for this particular tree will be 3, because you can see that you have one element here, then another element here and another element here. So total 3 elements are there on different locations, right? So that's why the width is 3. So you can say that if we determine this using the x-axis, right? Let's say we have the x-axis here, because x-axis is written like this, okay. If the root guy is the 0th coordinate, okay, then you can say 3 will be at the coordinate 1, x is equal to 1, and then 2 will be at the coordinate minus 1 here, correct? So you can see that total number of coordinates, different coordinates of x are how many? Total different coordinates of x are 3. That is why the width is coming out to be 3 according to the question here. Now let's say if we had another diagram, let's say we had 1, okay, then we had 2, then we had 3, right, then we had something like 4 here, then we had 5 here, then we had, let's say, 6 here, 7 here. So I have written the elements in any order. Now if you will observe, so what is the width of this particular given binary tree? So you can like vertical width. So you can say that on this particular x axis you have 4, here you have 3, here you have 1 and 6, here you have 3 and 7, and then here you have 5. So you can see that it is nothing but 1, 2, 3, 4, 5. The width is total 5. Now how can I keep a track of it? So if you will observe, let's write the x-axis here and let's see what will happen. So suppose that you will write the x-axis here, okay, and then for the root guy you will say that the value or the x-coordinate will be what? It will be 0. Now whenever you go on the right, the x-coordinate will increase. Whenever you go on the left, the x-coordinate will decrease. So if you go on the right, then x-coordinate will be 1 here. If you go on the right more, it will be 2. If you go on the left, it will be minus 1. If you go more left, it will be minus 2. So you can see that total number of different coordinate of x are how many? Total number of different coordinates are 5 here. Total number of distinct coordinates are 5, because you have got minus 2, minus 1, 0, 1 and 2. So total there are 5 different coordinates. This means that the width is basically 5, because you'll have 5 different lines drawn here. Okay, now let's take this sample and see how we can do it. So basically, whenever you are at a particular node, let's say you are at a particular current node, okay, and you have allocated it a x value. So if you will go on the left side, then the x coordinate for it will decrease by 1, so it will be x minus 1. If you are going to the right child, then for the right child, the coordinate will be with respect to the current guy which has the coordinate x, the coordinate for the right child will be x plus 1 here. So you can keep on putting all these coordinates inside the set, and whatever is the set size at the end, that is what you can return here, okay, because set will store all the unique coordinates of x. Okay, let's take the sample example. Let us say that we have got 1 here, okay, then we have got 2, then after that we have got 3 here, okay, then we have got 4 here, then after that we have got 5, then we have got 6, okay, then we have got 7, and then after that we have got something like 8 here, okay, and then we have got 9 here as well. Now what we will do is, when we'll be traversing the tree, so basically we'll start from the root node. So let's say we'll start from the root node as 0. If I'll go on the left side, then I'll mark the value as minus 1, right, and whenever I'll go for the right child, I'll increase the value by plus 1. So when I go on the left of 1, I'll have minus 1 there. So inside the set, what is being stored? So far 0 will be stored and minus 1 will also be stored. Now after that, with respect to 2, I'll go on the left. So basically the guy is 4, it exists. So the value of the coordinate will be minus 2. Minus 2 is also a different x coordinate. It will get updated. Now with respect to 2, if I'll call on the right, then what will happen? If I'll call on the right side, then I'll get the value as 0. So 0 is already present, because 1 and 5 are both on the coordinate 0. Now after that, we'll go back up to 1 as well. Now from 1 we'll call on the right, that is we'll call for 3. For 3 the coordinate is 1. If I go on the left, then the coordinate for 6 will be 0. So 1 is the new x-axis, so I'll update the value for 1 in the set. Now on the left you have 0, so no problem. Then on the right, when you'll call, so you'll have 2 here, okay. So 7 has the element 2, 7 has the x coordinate as 2, so you'll put it. Then after that, with respect to 6 also, if you will observe, so when you would have called for 6, obviously when you will come down, so with respect to 6 you will update the value as 0. Then 6 left is null, 6 right is what? 6 right is basically existing, so you'll mark the value as 1. 1 is already there inside the set. Then you go back up. Now from here you call for 7. When you'll call for 7, so you'll insert 2 inside the set. Then you call for the left, there is nothing. When you call for the right, then you have the node 9 existing, so the coordinate for it will be 3 because you're going on the right of the element 7. Now you'll put 3 as well. How many different coordinates are there? You can see 0, 1, minus 1, 0, minus 1, minus 2, 1, 2, 3. So total 6 different coordinates is what I can see. So I guess the vertical width should be 6. And you can see that the answer is coming out to be 6. So this is how we can solve this problem. Let's try and implement the code here. Okay. And then we'll see the time complexity as well. So what we will do here is, first of all, we'll declare a set for ourselves. So we'll declare unordered set here. Okay. And we'll store integers here. So let's write integer here because we'll be storing the different x coordinates here, right? Let's write it as st. Now after that, what we will do is we will call our recursive function. Okay, we'll pass the root here and we'll also pass the set here. Now at the end, whatever is the set size, that will be the final answer. So we'll return the set dot size. Now after this part is done, so what we will do is we'll write a void recursive function, and here we'll pass the current root. So let's say we'll pass the node star root. Okay, then we'll pass what? Like we'll also pass the set. So unordered underscore set int ampersand st. Okay, so whatever changes we'll make to the set, we want them to be visible. That is why we are writing like this. Now whenever I am at a root guy which is null, so whenever I am at a particular node which is null, so I should just return away from here. So I'll just call for the return. Now otherwise what will I do? Otherwise I'll call the recursive function for the root dot left here. Okay, and whenever I am at a particular node, so I'll call for the root dot left. Okay, I'll pass the set here. So all the elements that are on the left, their coordinates will be their x coordinates will be updated and they will be stored inside the set. Then after this, since I am at the current element as well, so inside the set I'll insert the current x coordinate. So initially I should pass the x coordinate as 0, and here also I'll have a x coordinate variable, let's say int x. Okay, so if I'm going on the left, so the x coordinate will decrease by 1. Otherwise, if I'm at the current element, I'll insert the current x coordinate inside the set. And when I call for the right, so I'll call for what? I'll call for the root's right child. Okay, here. And then after that, I'll pass the set here and I'll pass x plus 1 here. Okay, why we will pass x plus 1? The reason why we will pass x plus 1 is because when we are going on the right side, so the x coordinate will increase by 1. Now let's try and run it to see if it is working fine on the samples or not. It should work fine ideally. Okay, it is working fine on the samples. The answer is 6. Let's submit this code and then we'll see the rest of the complexity as well. Okay, so you can clearly see that the code gets accepted in the very first go. Now talking about the time complexity and the space complexity for the approach that we have written. So basically the time complexity for my code will be order of n, because in the worst case, we'll be iterating through all the n nodes in order to find the x axis for every node and store that inside the set if it is not present. Okay, and the space complexity will be how much? Space complexity will be order of n because we are taking a set, as well as it will be order of n because I am running a recursive function. So recursive stack space will take order of n time in the worst case if the tree is skewed or in only one direction, right? So the overall space complexity will also be linear, same as the time complexity. I hope that you have understood this problem clearly. In case you did, so make sure to comment down understood +1 as well in the chat. Thank you for watching this video. Make sure to hit the like button and keep coding, guys. Thank you.